Hi, and welcome to 1BV10 module, XPath Queries with Mendix. In this short video, I will introduce you XPath data query language and demonstrate its application in Mendix. Before you continue, make sure that you have completed 1BV10 module application data modeling with Mendix. The business application users will have many queries to be answered by filtering and retrieving their application data. For the small data model example here, the application's users may want to know the name of the customer who has the order with certain order ID, all orders of customers with name Stacy, customer with the maximum number of orders, or customers who have never placed an order. In essence, a business application is designed to meet the information needs of its users, which in turn requires a standard and structured language to filter and access some part of the application data. SQL, standard query language, being the most popular, there are many query languages used in software design. XPath is the query language used in Mendix application development. Using XPath language elements, you can create query expressions to filter and retrieve data. These expressions are called XPath expressions. In Mendix, an XPath expression comprises three elements: the query entity to retrieve, together with its module name, which is required for all expressions, constraints that applies to the query entity, and an attribute to retrieve, which are optional elements. As an additional XPath utility, Mendix provides aggregate functions that take XPath expressions as input and perform operations on the set of data that XPath expressions return. Four important functions are average, maximum, minimum, and summation functions. Here on the left, we see an XPath expression that returns customers that have a given postal code. On the right, we see another expression in an average function that averages out all orders that return from the XPath expression when executed. In an XPath expression, special characters are used to specify its elements, which are called XPath tokens. XPath expressions start with double slash, which refers to the entity of the query. Dots are used for specifying the preceding module name. We use single slash for indicating the next node on the path, and brackets for enclosing one or more constraints that applies to the query entity. Parentheses are used for grouping constraints in a constraint block. Let's create one expression together to illustrate the elements, the syntax, and the logic for creating XPath expressions. We will use our minimal customer order domain model and prepare an expression that returns the name of the customer who has the order with order ID 7168. The query entity is customer, which is created in project module order management. We will add a constraint to the set of all customers in the database such that the expression returns only the customers that match the constraint criteria. Here, our criteria is a simple one: the customer's order ID must match 7168. Since the association is one-to-many, that is, the matching order can belong to one customer, by design, we know that if there is an order with the given order ID and it is associated to a customer, then this constraint will return us only one customer. Finally, we will return the customer's name. Let's create the XPath query in steps. First, we write down the entity together with the constraint block. Then, we start building the constraint by first creating the association node that links customers to orders. Then, we add the next node, which is the order entity, and then another node to add the criteria, which is order ID equals 7168. We're done with the constraint part, and finally we add the final node to the path that returns the customer's name. We can add as many nodes as required. Here's an example query to return all order objects that contain an order line for a Kindle 7. When executed, this expression returns the orders based on a criteria that applies to the products of the order lines of the orders. As you can see, this involves linking the order entity to product entity over a path that includes two association nodes. You can have multiple constraints in an XPath expression. The constraints can be combined with each other with AND or logical keywords. AND means the results of the query should satisfy all constraints combined with AND. OR means the results of the query should satisfy at least one of the constraints. When there is not an AND or between the constraints, by default AND keyword is assumed. With parentheses, multiple criteria can be grouped into a single constraint. Here, we see an example with multiple constraints. The expressions in the first lines return customers that have name Janssen, who also have the given postal code. The third expression returns the customers with at least one order that amounts less than 100 euros and have either name Janssen or the given postal code. Mendix has built-in utility functions that comes handy in defining the constraints. They are particularly useful in selecting parts of datetime and string data attributes. Here, in the first example, year from datetime function is used to extract year information from order date data, which is stored as datetime. In the second, starts with string function is used, which constrains the leading part of name string data to the pattern JAN. Let's create one XPath expression and see it in action. We will create a query to return customers without an associated order using not constraint function. Before I begin, I will give you a tip for you. In Mendix, nearly in all cases, you'll select the query entity from configuration windows and we'll only write the constraint part of XPath expressions. For the demonstration, I created test data. I added 2 new customers without any orders. As we can see from the orders list, there is just one order, which is for customer Barış Özkan. Customers Sol and Jane do not have any orders. I will switch to Mendix Modular, stop the application, and add a new data grid under Customers grid that will show the customers without an order using an XPath expression. I will select XPath as the data source for this grid and select Customer Entity from the window as XPath Query Entity. In the XPath Constant Entry field, I will first type in not XPath constraint function and then include the path to nodes, first to order customer association and then to order entity. Autocomplete support for writing XPath expressions is enabled when you press Ctrl space. When the path in the constraint does not point to an order object, which means the association is empty, the not function returns true, meaning that the constraint is satisfied. I will remove all other buttons since this is a read-only view and rerun the application. Our XPath expression works. In this grid I added, I can see the customers who do not own any orders. In this short video, we learned what data queries are and how they are run using expressions in XPath query language. We have seen the structure and syntax for XPath and seen some of the Mendix built-in utility functions. This is the list of other resources I can recommend for learning XPath. You can learn further XPath details from XPath pages in Mendix official documentation. Also watch Bike Shop XPath examples. See you in the next module.